is to find the probability of compound events. So in order to do that, we kind of have to, first of all, recall old information. So if you could do this warm-up, get through those 4. They don't take too long. Then we have some new vocab to go over. So go ahead and take some time to do that. All right, let's go over these. Number 1. Does anyone want to provide the answer? Go ahead. Over 2? 1 over 2? 3 over 6? Yep. Very good. Number 2. Alec. Yes. Very good. 2/3. 1 is not a prime. Or sorry, I was thinking that one. Number 3. Yeah. Not quite. Not quite. So yeah, the prime numbers that we would have on a 6-sided die is 2, 3, 5. 1 does not count because 1 is not prime or composite. So we have 3 out of 6, which is 1/2. And number 4, what is the probability of rolling a 2-digit number? Geo. 0. No way that's going to happen. Very good. Are we okay with these? Yeah. Yeah, that's fine. 0 over 6, I'll get the message, yeah. That's perfectly fine. Alrighty, vocabulary for today. We have 3 very important vocab words. We have a compound event. Compound event is the union or intersection of 2 events. The union is like this first picture down at the bottom, where it's all of event A and all of event B. Everything is taken into consideration when we are asked about the union of A and B. The intersection of 2 events is just where they overlap. Just where they overlap. So we have compound events as the union or intersection of events. Overlapping events are like these first 2 diagrams where there are overlap. The disjoint or mutually exclusive events, those words can be used interchangeably. And that's like the third picture here where they have no outcomes in common. Overlapping events, they have at least 1, maybe more outcomes in common, but for disjoint or mutually exclusive, there are no outcomes in common. Still see some people writing. So now that we have these new vocab words, let's figure out how we would find the probability of compound events, now that we know what a compound event is. So, whoa. All right, the probability of a compound event. Make these a little new. These a little bit bigger for you. So the probability of compound events, we have 2 different scenarios here. If A and B are any 2 events, then the probability of A or B is the probability of A plus the probability of B minus the probability of A and B. Now down below we have if A and B are disjoint or mutually exclusive, then the probability of A or B is just probability of A plus the probability of B. I want you, while you're writing these down, take a moment and think, why are we subtracting the probability of A and B from that first part? Think about what is happening, and I think it helps to look at those 3 diagrams. Think about what we're doing. We're adding the probability of A and the probability of B. Then we have to subtract. Alec, do you have an idea? Yeah. I'm not sure if you're quite getting, you're talking about what I'm looking for, but Gio, let's see if you can. You're getting rid of the overlap. Yeah, so you're right about the union part. That's like kind of the picture we're looking at here. We have the probability of A, and then we have the probability of B. Well, we just counted that overlap 2 times, so we need to get rid of it at least for that 1 time so that we're only counting that middle section, that overlap, once. That's why we subtract probability of A and B. That's the intersection. Why don't we subtract it down here then? Why don't, yeah. Yeah, we don't need to subtract the overlap because they don't overlap. The probability of A and the probability of B, that's good. That's going to get A or B, and there's nothing we counted twice there because they don't overlap at all. Very good. All right, are we okay with these formulas? If we are okay, we are going to do an example. All right, find the probability of the disjoint event. A card is randomly selected from a standard deck of 52 cards. What is the probability that a 10 or a face card is chosen? So, start out by writing probability of 10 or face. Probability of picking a 10 or probability of picking a face. So let's do probability of 10, right? We're using our formulas right above, plus the probability of picking a face card. Do I need to subtract the probability of 10 and a face card? No. Ryan, why not? Yeah, there's no overlap. There's no such thing as picking a card that is a 10 and a face card. So there's no overlap. And you can even see it in the picture here. So can I have someone tell me what the probability of picking a 10 is out of this deck? Go ahead. 4/52. Very good. Plus the probability of picking a face card. Gio? 12/52. Very nice. So that gives us 16 out of 52. Is that a good answer? Should I just box that off? No. Luke, why not? Yeah, to what? Yeah, take out a 4, we're left with 4/13. Very nice. So 4/13 is a good answer. Like I said, I'm going to give you a couple different representations. That's 4/13 is the same thing as about 0.308, which is about 31%. So if you're saying to yourself, well, what am I calculating? You just figured out that the probability of picking a 10 or a face card out of a deck of 52 cards is 31%. So it's not very likely that's how it's going to happen. Are we okay with this example? All right, we have a little more complicated of an example here using those formulas we wrote down. So I want you to take a moment, read this through, and kind of write down as you read what these numbers that you're seeing throughout mean, because we're going to need to label here, and we're going to need to figure out what these probabilities are that they're talking about. So at least figure out what those numbers they're throwing at you mean in the problem. And right now, I will write. Alrighty, so if we're looking at this problem, we have the probability of randomly selecting a varsity athlete. We have the probability of randomly selecting an honor roll student. And they also told us the probability of selecting a varsity athlete or an honor roll student. So what are they asking us to find here? Yeah, go ahead. Yeah, when it's both, and that is the overlapping. Yeah, so we're looking for the probability of A and B, or the probability of varsity and honor roll. So the first thing I would say to do, yes, Gia. So that's the students that are either on the honor roll or are varsity athletes.
Right. So.
And we're trying to find the overlap. They're not
Yeah, but
including that.
the 74 and 51 have more than that.
The overlap is what we're looking for. What you're seeing is you see that there is an overlap, but they don't take that into consideration in the 113. 113 is just if they're a varsity athlete or they're on the honor roll, and we're going to look for that overlap that you're talking about. Good question. That's a good question. All right, so let's find the probability of all these separate things. The probability of randomly selecting a varsity athlete. What is that? Alec. 74 varsity athletes out of the whole 200. Very nice. You definitely could, but we're gonna have to use these fractions and add them or subtract them or some kind of operation, so I'd leave them with common denominators for now until you get to the end. Yeah, right. Yeah, you might have to fix that later. Right. You are correct. Probability of choosing a student that is on the honor roll. Jenna, go ahead. 51 over 200. You are correct. And then that last number that they give us, the probability of randomly selecting a student that is a varsity athlete or on the honor roll. Go ahead, Emily. Right. You are correct. So we have all the information we were given. We know what we're looking for. Now the only question I have for you is, well, what's wrong with our formula that we wrote down in our notes? I mean, like, what do we have to do? Because it doesn't look like the way we want it to look. Yeah, we have to. So let's write down our formula. That would be probability of varsity or honor roll is equal to the probability of varsity plus the probability of honor roll minus the overlap, varsity and honor roll. And I'm just taking this formula from the one we generically wrote down on the top of the page. And what Alec was saying is we need to subtract this over to the other side. And we need to subtract this to this side because we are trying to find this. We are trying to find the probability of randomly selecting a varsity athlete and an honor roll student. So we need to set this equal to something. So take a moment to solve for that. Rearrange. We're going to add the probability of choosing a varsity athlete and an honor roll student to both sides. So on this side we now have varsity and honor roll. Then after you add that probability of the varsity and the honor roll to both sides, you're going to want to subtract the probability of varsity or honor roll. Right, so I have to subtract this from both sides, Alex, still. I was just taking baby steps. You see? Did you get that, though? Okay, good. Sorry. I just want to make sure it's clear what we're doing here. We're not just pulling this out of nowhere. It's not magic. All right, probability of varsity and honor roll is going to equal the probability of varsity plus the probability of picking an honor roll student minus varsity or honor roll. All right, we have these numbers. These are numbers that we have. Probability of randomly selecting a varsity athlete is 74 over 200. Probability of selecting a student on the honor roll. What's that one? 51 over 200. Thank you. And the last one, we have to subtract off the probability of picking a varsity athlete or honor roll. So now, this is where it comes in handy to have that common denominator. Someone tell me what they get for that fraction there. Hmm? 12 over 200, you are correct. Is that how I should leave my answer? No. What should I leave it as? 3 over 50 is a good final answer. You could also say 0.06 or 6%. Do you have a good chance of randomly selecting a student that is a varsity athlete and? No, yeah, that's very small percent chance that would happen. Very small. Are we okay with that example though? Yeah. Didn't I have what? You see? You're okay? Okay. We're okay to move on? No questions? All right. Alrighty. Let me move this for you. So, before you start copying these down, let me make sure. Alrighty. We have another vocab word, the complement of an event. An event is a complement of an event is read as a bar. There's just a bar over that A. The event A bar is called the complement of an event, and it's everything that's not in A. So A is made up of a certain amount of outcomes. The complement of A is everything else that is not in A. So that first thing you're writing there is the definition of the complement. The second piece of information that you are going to write down is the probability of the complement of an event, how we find this probability. The probability of the complement of A, we'll say, is 1 minus the probability of A. Why did we subtract it from 1? Why are we subtracting the probability of A from 1? Kristen, go ahead. Yeah, 1 is the whole. 1 is like 100%. That's going to happen. 100% is the highest we can get with probability. And so from the whole, we're subtracting the probability of A because whatever's left over is the complement by the definition. Does that make sense? Why? That's how we find it. So what we're going to do now, we're going to go ahead and do one example with complements. Make sure everyone has that. Okay? Alrighty. We have 2 6-sided dice that are rolled, and when you do that, there are 36 possible outcomes shown right there for you. We have to find the probability of the given events. We have to find the probability of randomly selecting an outcome where the sum is not 6. So we're finding the probability when the sum is not 6. So to do this, it's probably easier if we do 1 minus. That's the point of this, is we're not looking for the probability of sum not being 6. We're taking 1 minus the probability that it is 6. Yeah. So probability sum is 6. Right? Because those two things are complements. Probability of sum not being 6. Well, everything else is when the sum is 6. All right. 1 minus, you may need to take a moment, look through all the different options. They're all up there for you. And figure out how many different times you would get the sum of 6. Noah? 5 of them, yes. So what's the probability? Yeah, 5 over 36, very nice. So now we need a common denominator. Well, 1 is just like 36 over 36. Subtracting off 5 over 36, we're left with 31 over 36 as the probability of the sum not being 6. That's about 86% chance. It's about 86. There's some rounding involved. But that's a really high chance that that would occur. And if you think about it, that makes sense. Only 5 out of these 36, the sum gives you 6. So you have a really good chance of picking any of those other 31 options. All right, part B, the sum is less than or equal to 9. Probability of the sum being less than or equal to 9. Now, we're going to do 1 minus the complement, but we need to think about what is everything else. If we have the probability of the sum being less than or equal to 9, what is going to be the complement that we want to subtract from 1 to get that probability? Take a moment to think about it. Go ahead, Lexi. Yeah, the sum is greater than 9. Can I ask you why you didn't include like greater than or equal to? Right. Yeah, they already included 9 in this part, so we can't include it here. It's everything else. We don't repeat there when we have complements. Very good. All right, so we now have to figure out what the probability of the sum being greater than 9 is. So you can go ahead and take a moment and look at those options again. That's why I put the diagram there. I'll let everyone give that a try. Luke, do you have the probability of the sum being greater than 9? So 5 would be just like the number of items, but we need the probability, so it's something out of the whole, out of all of the outcomes. So the probability of something occurring, like up here we have the probability of the sum being 6 is 5 of these out of all 36. 6 out of 36. There are 6 times in which the sum is greater than 9 out of the 36 options. Very good. So now we need to do a little fraction subtraction. Well, that's hard to say. Fraction subtraction. All right, 36 minus 6, we get 36ths. A better answer to that would be 5 out of 6. Hopefully you realize that needs to be reduced. This is about 0.83 or 83%. So this is a little bit less likely than that, but there's still very high chance that either of these would occur. Are we okay with this one? How we use complements to find probabilities? Yeah? Okay. From here you have 1, 2, 3, and then 4, 5 independent practices. And I'll give you some time to work on those. When I feel like everyone's kind of wrapping up with that, I'll put the answers up there so you can check them. And then if there's still time left, you can go ahead and get started on your homework. But for now, I would like you to work on those independent practices. All right, let's get the answers up here. So 5 over 6, 0.83. All right, I put the answers to 1, 2, and 3 up there. So make sure you check that out. And if you have questions, let me know. Once I see that most people have checked their answers, I'll flip to 4 and 5 and put the answers down for those ones. I'm going to go ahead and put the answers to 4 and 5 up there. Take a moment, check those ones.